computer. Okay, well, welcome everybody to Earthbird seminars. This is an experiment. We're coming out of Rice University in Houston, Texas right now, 7 p.m. And Earthbirds, the goal of Earthbirds is really to showcase the stories behind scientists and the science that they do, and put a human side to scientists and all the things that we do. And it's called Earthbird because it's about our planet, from the core to the atmosphere to the life on the planet. And the bird part is just saying, well, some birds kind of wander around the planet, and that's kind of what we like to do. So here we go. I'm going to introduce to you Liz Vanacore, and thank you so much for being able to come. Liz, she is a seismologist, and she actually started off at Virginia Tech for a bachelor's, then came to Rice University and got her PhD. And then after that, did a postdoc at Australian National University and also University of Leeds. And then she found herself in at the University of Puerto Rico, where she's been about 6 years. So she's an associate professor at University of Puerto Rico, and she's also at the Puerto Rico Seismic Network. So welcome, Liz. And maybe to start off with, I always like to ask, so you're a seismologist. Can you tell me a little bit about how you got to be a seismologist? And then we're going to ask you, what is seismology a little bit?
All right, thank you. It's a pleasure to be here and see some old names I haven't heard from in a while on the chat. Well, I guess if you want to know how I got to be a seismologist, it probably started with my fascination with rocks. Infamously, when I was in grade school, my sister and I and my best friend Kelly, we dug up a rock during recess and smuggled it in our backpacks back home to our house. And this was a rock that was about almost as big as our backpack at the time. So it was about 20, 30-pound sample.
Wow.
And then in high school, I had an incredible physics teacher, Mr. Malkowski. And so when I think about careers, I wanted to be in a mixed, the fact I loved rocks and geology with the physics. And that kind of led me down the path of geophysics. And then eventually got fascinated by earthquakes and earth imaging. So basically what the structure, what does the earth look like on the inside? And it went from there.
and here you are. Do you still have that rock?
Actually, it ended up staying in my old parents' house in Media. They did not want to move it. They did not want to move to Florida with them. So it's now. I know where it is.
That's what matters. Okay. Yeah. Well, thank you for that story. And so you found seismology, and I think so Liz gave me a few slides, and I think this is a perfect time to talk about what seismology is for a broad audience. And I'm going to share your slide here, and maybe you can tell us a little more from here, and just tell me when to click. All
right. Well, when you're talking about seismology, you're talking about earthquakes and anything associated with earthquakes. Earthquakes in general are defined by movement on a fault or faults. And most of these occur along, we'll get to about this later, but most of these occur what we call plate boundaries, where big plates on the earth interact with each other and make these big faults. You might think of places like San Andreas, or you might think about the events in Tohoku or Indonesia. And those are the types of events and earthquakes that right now I'm working on in Puerto Rico a bit more. So what I decided to show here is a bit of earthquake music. So what does a seismologist see when an earthquake happens? And what we see are these squiggly lines called waveforms. And these waveforms tell us about the Earth's structure. And you go ahead and click on them both. So you can see that there are different types of waves based on their motion. And what I'm also showing is you can actually, these waves are akin to any type of acoustic wave. So what I'm showing with this earthquake quote unquote music is what I've done is changed the speed at which those waveforms are coming in. So you have to set it up so you can hear it in the human ear. And that's actually the 6.4 event that happened in Puerto Rico in January, recorded in Disney World. So it's a good distance away. Yeah. And so if you're hearing that earthquake, you hear first the P wave, followed by what we call P wave, which is a primary wave, followed by a secondary wave, and then finally those big surface waves. And when people talk about shaking and what they feel during an earthquake, it's usually not the P wave, but rather the S waves and the surface waves. So you know they have much bigger amplitude. So that's part of why I research here.
These right here that I'm pointing out.
Yeah, those are the surface waves. Yeah.
Those are bad news.
Yeah. Yes. Yeah, those are the most destructive waves.
So in this figure right here, which shows the propagation of essentially these sound waves, plastic waves, maybe not everyone knows, how long does it take for when an earthquake happens right here to reach all the way over here and jiggle the cow?
Well, it depends on how far away. So if you're right near the source, you're talking seconds it's arriving. And so that's for what we call a local event. But if you're going across the Earth, you're talking 30, 40 minutes that those waves take to get there. And they aren't felt or seen by a human. Once they're going that far away, they're only seen by instruments that we put in the ground called seismometers. Like if it's local or regional, you may feel those, and those are usually in that first minute or so.
And how fast do they sort of go, just for everyone? Oh,
yeah, now my brain is going to, because I'm thinking now in crustal terms as a local. Talking local, you can be going like, if you're in mantle, mantle starts about 8 kilometers a second, which is deeper in the Earth. But shallower, you're talking 5, 6 kilometers a second for a P wave. So we're talking scaled kilometers per second. So it gets changes with depth. So usually the deeper you go, the faster the waves will move. Except when you hit the core, which is liquid, which means no S wave, it's 0 kilometers a second. And P waves are a bit inhibited because it's liquid.
I really like this graph or this figure that you made, turning it into a spectrogram. It's like the color of an earthquake or the music of an earthquake.
Yeah. Yeah. Well, it is actually, I have to give credit here. This is a code produced by the USGS for making earthquake music in MATLAB. So that is freely available online.
Okay, it's beautiful. It just looks so beautiful with all these beautiful waveforms here. I think you mentioned the humans probably can't feel these more distant earthquakes, and certainly not the small earthquakes. And so you have seismometers to see that or hear it. You're listening to the earth, and I think here's a slide of some of your seismometers in Puerto Rico. You want to tell us how these work a little?
Well, I'm going to start by saying the Puerto Rico Seismic Network, we're actually more than a seismic network. I would make the argument that we're probably closer to a plate boundary observatory. We not only have seismometers, which are instruments which are sensitive to the ground motion. We also have GPS stations across the island, which look for longer term movement, Earth movement, as well as we also have sea level stages to look for tsunami. So we are a holistic network. We have about 30 seismometers, not only in Puerto Rico, but also the Virgin Islands and the Dominican Republic. And then on top of that, there's data sharing in the Caribbean. So we have a couple hundred stations coming into our network at real time. So it's 24 hours a day, 7 days a week, because we are a 24-hour network because there's a tsunami risk in the Caribbean.
And this network, actually, there's all over the world, right? There's a seismic network listening to.
Yes, there's global networks. But in the Caribbean, we actually have, if you ever go and look at data sites, there's something called the Caribe EWS, which is the Caribbean Early Warning System. It's made for tsunami. And what that is a subset of stations that includes Puerto Rico Seismic Network, but also stations in North America, South America, Central America, and all the other Caribbean islands, as well as a couple further out, like in Africa and Europe, just to make sure we don't put a teleseismic event from, like the one we had that was in Iceland a couple days ago, into the Caribbean. So we have that network, and that's the data sharing, and that started in about 2006, which made our network sensitivity increase significantly. So we went from having just our 30 stations to having a couple hundred stations.
Just out of curiosity, how many people, how big is the operation at the Puerto Rico Seismic?
All right. The Puerto Rico Seismic Network, we do everything from 24/7 analysis, which includes both students and staff members. So our analysis is what I call the heart of the network. And so we have right now about 10 full-time analysts, 3 professors, myself, Alberto Lopez, and Dr. Victor Waifano. And then on top of the analysts, we also have students. So these are undergraduate and graduate students who work at the network. So if they're doing research with us, they usually will get the opportunity to get some real world experience at the same time. On top of that, we have a technician group, which is 3 technical experts who go out and help with servicing the stations, making sure stations are working. We have our own information technology department because that much data has a lot of computers involved. We have our own administration, which are 3 very, very talented administrative workers who work miracles. And then we have our education and outreach department, which is another very important department because they're the ones who help me as a scientist talk to the public or translate something. If there's a major event, I would say, okay, here's all the figures, here's all the information, and then they help translate that and put that into a Facebook post or help with the press, arrange a press conference or do what needs to be done. So we do everything.
That's great. And I think we're gonna come back to that theme very soon. I think right now it's perfect to move to about a little bit about the geology of Puerto Rico. I think a lot in the mainland don't know that much about Puerto Rico geology, and so let alone that it has earthquakes. Trying to see, this is not.
Can I ask a quick question while you work on that, Cin-Ty?
Yeah, go ahead. Here we go.
Go ahead.
So you mentioned all the massive amounts of data that these networks produce. What do you do with it? Like, where does it go? That's one thing I've always wondered about this stuff.
Well, in our case, all of our data for the seismic data is also cataloged at the IRIS Institute for, I can never get this, the consortium, IRIS Consortium, which is iris.edu. And that means that we have essentially a backend data. We also have a local storage. Strong motion will also go into the National Archives of Strong Motion data. And then for GPS data, that goes to UNESCO. And sea level data that goes to NOAA and the IOC. So they all go to larger archives as backup.
All that data is publicly available, right?
Yes, and this is going to be me on a soapbox for a second, if you don't mind.
Yeah.
Is a lot of people, we have open data.
Yeah.
And a lot of times researchers don't give credit to the networks when they use our data. And we have, Puerto Rico Seismic Network, we have a DOI. So if you use our data, 1, please let me know. And 2nd, please give us credit in the DOI because there's a lot of work that goes into keeping that data working and archived.
That's a really good point. Hope everyone heard that. Give credit to where it's due because they're doing so much hard work to collect the data and archive the data. Yeah, so let's go to Puerto Rico. Let's start talking about where it is, why it's interesting geologically, why does it have earthquakes, and I'll start with this plate tectonic map. Do you want to say a few things about it?
I guess the easiest way to think about it is Puerto Rico and the Virgin Islands, because technically I work for both of them, is located on the northeast corner of the Caribbean plate. So it's essentially where the yellow dot is approximately on the slide. So what's happening along that area is the North American plate is kind of coming almost, moving almost westward relative to the Caribbean plate. And the Southern American plate is kind of squeezing, because the Caribbean plate is being squeezed between both the North American and South American plates. As far as I usually just talk about the North American plate, because that's the border I'm on. So in that North American plate, you actually have something called oblique subduction. So what that is essentially think about two cars crashing. Two cars crashing directly would be something like the Indonesia or Tehuco style of border. Or even along, to go further south and east of the yellow dot, along that Lesser Antilles is traditional subduction, head-on collision. What's happening in the northeastern Caribbean is more of a glancing side-blow collision. So they're coming in at a very oblique, high oblique angle. So they're almost moving parallel, but there's a bit of compression. And this bit of compression is what makes the Northeast Caribbean very complicated and almost a Gordian knot. They're trying to pull out all the information when you're looking at this, looking at the detail. So the way I think about it is the Northeast Caribbean is the crumple zone of the Caribbean plate.
So there's quite a bit of strike slip motion too, right? Then
there's an extreme amount of strike slip motion. Yeah.
Kind of like the San Andreas fault, but it's got a little bit more compression than the San Andreas. I think your next, maybe your next slide
shows the detail.
A little bit more detail.
Yeah. This actually is the detailed look. So basically now looking at where that yellow dot was. The black box is what we call the area of responsibility. So the earthquake in that box that you see in the USGS catalog is 99.9% of the time located in Mayagüez, Puerto Rico, by our analysts, or myself, or Victor, or so when someone at our network has looked at that event and located. So within that, what I have on here are significant events, as well as the major faults. Not all the faults, these are just the big ones. So I'm going to start out by talking about the major faults. The big one you can see all the way up top is the Puerto Rico Trench. That trench is over 8,000 meters deep. So it's one of the deepest trenches in the Atlantic and the world. Wow,
I didn't realize it was that deep. Huh.
Yes, that's why it took by hook or by crook to get. You have to have ultra deep new technology to get ocean bottom seismometers down there. And then you have these more strike slip fault zones, should be like the septentrional fault and the 19-degree northern fault zone. And then you have between them the Mona Canyon, which is extension. So Puerto Rico and the Virgin Islands are actually kind of moving away counterclockwise from the Dominican Republic. And then you have along through Puerto Rico, we have the Great Northern and the Great Southern Puerto Rico fault zones, which are primarily strike slip. And then you have the Laja, Punta Motagua, Boquerón, and that's where we're having the current activity. The 2020 Southwest Puerto Rico seismic sequence and the 6.4, which is the red star, is occurring along this almost beginning fault zone, which has a mix of faults that are moving apart and faults that are moving next to each other. You go further south, you have what's either a backstop or essentially the end of deformation. It's another compressional area, which is the Muertos Trail. And then you have the Anegada Trail, the Anegada Passage, which is also more extension. I do want to take a moment to talk about some of these earthquakes, if I can. It's important to note that there have been large earthquakes in Puerto Rico and the Virgin Islands in the past. You start out with the 1787 event, which some people say is like a magnitude 8. We don't know if that was a megathrust or not. There was no recorded tsunami. You had 1867, it's a 7.3. That created a tsunami that impacted Puerto Rico and the Virgin Islands. You look at 1918, that was another 7.3. 6 meters of tsunami in the northwest corner of Puerto Rico. 1943, another major event. And it's 1946 at 7.8 in the Dominican Republic, which also generated a tsunami. So really looking at Puerto Rico is like, this is a high hazard for not just earthquakes, but also tsunamis, because most of the faults are offshore.
Yeah, that's very interesting. I'm not sure everyone actually knows that up in the mainland. You talk about these magnitude and some controversy over the size of some of these historical earthquakes. Yeah. Maybe what controls the size of these earthquakes, and what do you think is the largest type of earthquake that you can actually get in these sorts of fault systems in Puerto Rico?
Well, okay, if you're going to say the largest system, the largest one would probably be something along the Puerto Rico Trench, if that is coupled. So if the trench if the subducting plate which is the North American plate and the Caribbean plate are in contact along that trench, and we don't know if that is the case. So that is a major scientific question that we need to answer. If that's coupled, then yes, you can have a large event. And in 1787, there was a large event. Yeah. So right now we have, like, for our modeling, we use about 8.5. But the question is, can it be larger? And but that would probably be the largest one. And if you look at 1946, but what can really control the size of the fault is the dimensions of the fault and how much the fault can move, and if it stays on one fault. Because if you look at modern seismology, look at New Zealand, which had the Calacorta event, that earthquake actually occurred across multiple faults. And so that might be something that can occur when you have these incipient zones like in the southwest Puerto Rico. If you look at the most dangerous fault for Puerto Rico, I would make the argument, you look at southwestern Puerto Rico, looking at Laja, Punta Maracaba, Boquerón system. So all like where the red star is, where we're having a current activity. I would call that the most dangerous, primarily because on land it's populated and it's one of the more active areas on the island, historically. So.
Yeah, this is, I just didn't know that you could get potentially magnitude 8s in the Caribbean, and that's something we think of as big faults in San Andreas or big subduction zones, and magnitude 8 is just huge. That'd be devastating.
Yeah, think about magnitude 8. We actually had a couple recently over near Honduras, which we did have to respond to at the network. Magnitude, I think there was one a couple of years ago. Yeah.
Oh wow. Yeah. Well, Honduras. Yeah, that's a subduction zone.
Yeah, exactly.
Yeah.
Yeah. Actually, that was actually on the strike slope on the northern boundary of the Caribbean. Okay. Yeah. But it's one of those things that you can have large earthquakes in the Caribbean. It's just most people think of the Caribbean, they think of rum and beaches.
Yeah, and I think a lot of us think it's mostly strike slip faults. But there is that trench. Even I didn't know that. I don't know if you want to talk about this slide.
Well, this is just the seismicity we've recorded at the network since 1986. And it's important to note that we don't have a lot of data compared to someplace like California, because their network started in the early 1900s. The network moved to the University of Puerto Rico migrants around 1986. And then you had a few short periods and they were paper records. We are in the process of digitizing all of those records. So we have a group that they're scanning all of our paper records. And those paper records go up to the early 2000s. So those are short period, and you only have 4 or 5 stations, primarily on the west side of the island. So we are missing a lot of data. So while we can see the larger events, we might not necessarily see all the microseismicity that we now see today. On island, we can see some very small events in the southwest Puerto Rico seismic sequence, and we've seen most that. If you look at southwest Puerto Rico, you kind of see that cloud of events. We can locate below magnitude 1. Just given our station density in the area. The issue we have is we're an island, and when most of the earthquakes are offshore, it's very difficult to image those. So we don't have magnitude completeness down to magnitude 0. We only have completeness down to about 2.7 in the trench area. That's just geometry, because we can't put stations in the water in real time.
These sorts of maps, I guess, then also really help you map out the seismic hazard risk, at least in part, right? Certainly where the earthquakes are happening.
That is part of it. But we also have internally, we look at sometimes, like we say, we can figure out if we have a gap in our network. We actually have a fairly dense network right now. But if we say are getting a number of events on a station that it's only appearing on that station, we might go and say, okay, we need to go put a couple more stations in that area. So that helps us design where we're going to put more stations next. Because the network always is growing through time as funding is available. Because more data and ability to locate more earthquakes will let us know more about the hazard and be able to make a better hazard map, which is something that's going to be worked on soon, hopefully.
Let me ask then, well, here's the other slide comparing the number of events with California, and I guess you can talk about this, but I also want to know what are the major risks and how do you communicate these risks to Puerto Rico? Is Puerto Rico well prepared? Are the people, are the infrastructure prepared for these earthquakes? How does it compare to California?
Yeah. Well, I'm going to start with the story because I linked that. Your question actually kind of links into why I made this slide. Right now, the Puerto Rico Seismic Network has been really working with this program called QuakeSmart, which is a national program where they get local experts to come in and help talk about earthquake hazard for businesses. And one thing I faced immediately is people going, oh, we haven't had a large earthquake since 1918. It's not going to happen next to us. Now, after 2020, we don't have that problem anymore because the earthquake did have a major impact. But how do I get people to prioritize earthquakes over hurricanes, which happen every year? So I said, okay, most people when think about earthquakes, they think about California. So I just ran numbers for 3 years. My graduate student, Diego Carlos, has run it for a longer time period, and it does hold. Because he normalized it by area, and it basically shows that Puerto Rico, if you compare us apples to apples, saying magnitude to magnitude, saying greater than 2.5, greater than 3.5, because we don't have that completeness, we actually have per unit square area more earthquakes, which should be a hint that earthquakes are a hazard. So that's why I actually made this slide, is to try to convince people to take the hazard seriously in Puerto Rico.
How do you,
and then,
oh, sorry, go ahead.
Oh, go ahead.
Well, you mentioned hurricanes, which come almost every year. Of course, the worst case scenario would be a hurricane and an earthquake together, like a hurricane.
Don't, knock on wood. Don't say that.
Yeah, but how do you communicate this? And how do you communicate this to the public and to have it be taken as a really high priority? What are the challenges, I guess?
Well, I guess the biggest challenge is we have, like, if you're looking at if you're looking at earthquakes and tsunamis, because they are a coupled hazard. If you're looking at earthquakes and tsunamis versus a hurricane, you have people who have businesses, people who are emergency managers, who say, I know there's going to be a hurricane every year, versus what we call, earthquakes are what we call a short fuse event. Is there's no warning, they happen, they're rare, but they are quite destructive when they do. So it's actually one of the biggest challenges we have. Things that we do are our education and outreach department. I have to shout out to Guillermo Gomez, who's the coordinator, do an incredible job of going out and giving talks, providing educational materials in both English and Spanish. We have all this information on our website available for people to use, how to make emergency backpacks, how to prepare for earthquakes. And then we have 2 exercises a year. We have one, which was Shakeout, which was last week, and that's every October. And then in March, we have a tsunami exercise called Caribe Week. So that's where we really motivate the public to kind of practice their earthquake and tsunami plans. So we do a large campaign at those times. And then sometimes it's giving a talk for FEMA or going out to a high school or doing that outreach day to day, which our education department is usually out. Pre-COVID, they were out about 3 to 4 days a week, going to schools, going to businesses, going to anyone that wanted to learn about earthquake hazard and what to do, prepare. That being said, preparation is more important than what happens during or after an earthquake. So without that preparation, no matter where you are, you're toast. And one thing that we have in Puerto Rico is a lot of our buildings are made, including my house, is made with reinforced concrete, primarily because we have to withstand the hurricanes every year. Reinforced concrete is not the best material for earthquakes. So we have this double-edged sword. And then along with that, we have, landslides that happen.
Oh, yeah. Yeah, it's a very mountainous country and not part of the country, and very wet, so landslides as well. What are there any lessons that do you look to other Caribbean islands? I remember that big Haiti earthquake, which I think was only a 7, but caused so much devastation, and that has that been brought in to inform the public of what potentially could happen in Puerto Rico? Or
to a bit, I have used pictures from Haiti, from the Haiti earthquake and talks to show this is what happens to colonial buildings, unregulated buildings. To say, look, if you have a house, you need to get it inspected and get it built throughout the code, because Puerto Rico does follow the international earthquake code. If your house is built to code. When I bought my house, that was one of the first things I checked. Like, hey, it's built to code, we're good. I have the plans, so if I ever need to retrofit, I can retrofit. And that's an important thing. And one thing that's unique in the Caribbean with the ocean islands is we do get a lot of ground shaking. And this is partly due to topography and partly due to you have these hard volcanic rocks and then soft sediment on top. Oh, that's perfect. Sorry.
I put that one in because I knew you were going to talk about.
So this is work by my former master's student and my current PhD student, one on left and the right, respectively. And one is looking at amplification. So what we're showing on the left is the same earthquake. This one is, I think this is the 6.0 we had in September up in the Mona Canyon. Same earthquake. These stations are just a few kilometers apart. The 2 top ones are on bedrock. The 2 bottom ones are on soil. And so this is just a difference of a couple kilometers, and you can see the amplitude of the waves are very different. So if you're on the softer soil, your house and you experience a lot more shaking during the earthquake. And it's quite variable in Puerto Rico. So one thing that we're doing is working on ground motion equations to figure out how to improve this for the maps, and also trying to get these site effects in to say, if you know what your VS30 is, this is what VS30 is a measurement of velocity of soil, which can help you predict how big those waves will be. So this is part of work that I'm doing as well, collaborating with the USGS as well as the Puerto Rico Strong Motion Program in civil engineering. Both of my students there are actually civil engineers, not geologists.
This is an important issue because I remember the Loma Prieta earthquake in California back in the 80s. I think it was the 80s, but a lot of the damage actually occurred fairly far away, but it was because it was buildings were built on fill and amplified seismic waves.
Yeah, actually, we saw something similar during the 6.4. There's a town called Utuado near the center of the island. They had the most shaking during the 6.4, even compared to towns that were right by the event. So it is a major factor for us in the islands.
Is there an early warning system being developed, or is that useful for Puerto Rico?
Well, I think right now, for us to be able to do that, one's going to take international collaboration. Because if you think about an event, for us, like it might be that we might be able to see an event and maybe provide warning for Dominican Republic, and they might provide warning for us as well. So you start, and then you have the British and the U.S. Virgin Islands. So US is easy, but British, like we still work with them. It's a bit confusing. So I think it's something that we want to work towards long term. But first thing you have to do is feasibility study. Because you're talking earthquake early warning, you have to have a highly dense network near your earthquake sources. So we already have a problem with our sources being offshore. You have to have a robust and fast communications line, which sometimes on the islands is not the case. So like those are two key elements, and you have to have high latency, and which is basically how fast does the information data get from the station to the network. So first thing would be the feasibility study and see how we lay out those three factors, and go from there.
Warning about, this is your other slide, warning about tsunami risk, from earthquakes from Puerto Rico or anywhere along the Caribbean margin. I know you talked about tsunamis more, but this is a nice visual that you provided. You want to say more about this? How extensive?
This is actually showing historical tsunamis in the Caribbean. The one thing I always point out to people is the scale by the maximum height, and the largest heights you see are in northeastern Caribbean. This is actually in the Virgin Islands. That's actually from I think the 1867 event. Don't quote me on that though. Another thing to note is we don't just have tsunamis from earthquakes. We also have them from volcanoes. And even if you look at the 1918 event in Puerto Rico, that might have been earthquakes plus an underwater landslide. So this is stuff that the volcano and landslides and non-thrust events, which is primarily what we have in Puerto Rico. 1918 was a normal fault. 1867, normal fault. So basically, they're spreading. So how do you deal with those types of events?
And this is the internet. Are over here, mostly.
Yes, they're mostly there, and they're actually monitored by our colleagues at the Seismic Research Center, as well as the French have some observatories. So it is an international effort. So there's activity in Kikumjeni, which is one of the underwater volcanoes along the Western Antilles. We'll get an email from the Seismic Research Center saying, here's the alert level, here's what we think is going on. So we are aware for Puerto Rico and the Virgin Islands.
And these tsunamis over here in Central America, they're coming from they're coming from some subduction. Yeah, they're coming from some subduction. The Panama event, here
especially, those can impact Puerto Rico. We have run those as Caribe wave exercises. Also, the ones off of Venezuela are of great concern.
The good thing for us living in Houston is we don't have to worry about Puerto Rican tsunamis. I guess we have to worry about.
But you do have to worry about landslides, different ones.
Landslides, they can make it this way, that far, the tsunami?
You have the Gulf of Mexico has a large sediment basin.
Oh yeah.
And so I would make the argument if you live along the coast, know if you're in a tsunami evacuation zone. Because that's something that Puerto Rico.
We don't have.
Yeah, something Puerto Rico has done. Yeah.
If we had an earthquake here, we'd all just shake off and float into the Gulf of Mexico. Just all be liquefaction.
You'd have liquefaction, yeah. That would be an issue in Houston.
I thought, what are we're doing? Okay. This last slide, this is more about basic research on interrogating the deep structure beneath Puerto Rico, and that's a different way of using seismic waves and earthquakes than what so far we've been talking about. Do you want to touch on this work, this new project that you started?
Yeah. Well, yeah, so I have one old project. The bottom two are things I'm trying to write up right now for my current grant, and then the next one is a grant that just got funded. So these are essentially, I'm trying to bottom is the teleseismic and the local tomography. And what tomography is essentially is a CAT scan of the Earth, MRI of the Earth. So you can see the structure. Usually we use redite and bluite. Redite being slow, bluite being fast. Here I use more green orange. It's a little bit more colorblind friendly. So really, you can say is that we do have some resolution beneath the island. In the one on the left, don't believe anything that's shallower than like 40 kilometers. So essentially, you can paste the one on the right onto the one on the left. And so you can see a little bit along. This is along mostly the west coast area, so where we have the current southwest seismic sequence. So on the one on the left, you can see a bit of the slab beneath Puerto Rico, and maybe a little bit of Muerto coming in from the other way, kind of making that V. Unfortunately, don't have a lot of resolution because you don't have a lot of station aperture. The one on the right is using local earthquakes with our station. You can see a lot beneath the island. So you can see, if you look where the light blue is, that light blue line would be roughly what we call the moho. So where you go from the crust to the mantle, based on velocity. And so what you see is like around 60 to 80 is where you're near the core of the island.
Okay.
So basically that's where you get to thickest.
Trench over here.
Here you don't have a lot of resolution. It's like you start that's like right around Muertos and go up around 40 is where you start entering the island, and 60 to 80 you're getting to the core of the island, and about 100 you're leaving the island. 100 you're leaving the island. Yeah. So essentially what you're seeing is you get a thicker crust beneath the core of the island, and it thins out to about 20 or so when you go to the oceanic. So it's nothing unexpected. But it is good to have that image because now you can help use that data as a starting model for the work that will be going on once COVID clears up and we can start doing field work again. This is the upper right is funding that just got funded. It's essentially doing onshore, offshore seismic lines, active, passive. So there's going to be broadband array that goes north-south across the center of the island. Those stations will be out for over a year. But when they're shooting, we're going to put a bunch of short periods in at about 500 meter spacing. And those red lines are where we're going to be putting active source lines with the lane. So hopefully with that, the aim is to look at that coupling issue that I mentioned earlier with the Puerto Rico trench, and figure out if that is coupled. If they're sealed together and locked, then that means that we need to look at larger events, mega threat type events in Puerto Rico. But if they're not locked, that tells us a little bit that the tsunami risk might not be as bad. So that's really the big question. And luckily, there's also fun in that grant. We also are gaining ultra deep OBSs, which can actually go down into the trench, which I'm really excited about. First data coming out there.
That'll be very interesting. Thank you for that. That sounds like a really neat project to learn more about what's going on underneath Puerto Rico and the surroundings. I guess I thought maybe we want to leave some time for the audience to ask some questions. But before we do that, we've had a nice tour of your research and how your research impacts society. And looking at your CV, you've come a long way. And I just wanted to ask, do you have advice for people who are just starting, like students? You happy where you are, and what were some of the challenges?
I guess I'll say, if you asked me 5 years ago or 6 years ago if I'd be doing what I'm doing today, I would have been like, oh no, I'm a deep earther. I work on ultra low velocity zones. And I applied for the job I'm in because my advisor, my postdoc advisor at Leeds told me, you'd be nuts. It's a research, fully funded. You don't have to worry about soft money. Go for it. And I went for it. And it dropped me into this world that I had no idea existed. I mean, I went from being a just a deep earth researcher that having to deal with policy and international policy, UNESCO stuff, federals, and so it was a really large learning curve and daunting. But I was lucky enough I had some good mentors, especially I wanted to give a shout out to Krista von Hillebrandt, because she helped me through probably when I did my first, I was going to tell you an embarrassing story. My first UNESCO meeting for AWS, I had no clue what I was doing. I had never done UNESCO formal policy work before. And she helped me fix and get through and do what needed to be done. And so I learned more in that 2 hours that she had spent a couple helping me and telling me what to do. And then off I went. So I think the big thing is don't be afraid to change. And you never know until you try and find your niche. And don't be afraid to move across the world. It's worth it. Absolutely worth it.
that is a really good story to hear and inspiring. And yeah, don't be afraid to change. Yeah, you really, I've seen your path, and you've come far, and you've taken the path that, I mean, from deep earth to looking at policy and surface deformation and earthquake hazards. It's really impressive. Well, in the last sort of 10 minutes, I think we should open up for questions here. Anyone on the panel or?
Yeah, so I have a question, and it's like not related to the science, but in your talk, you describe like 4 different kinds of disasters: hurricanes, earthquakes, landslides, and tsunamis, everything. And like right now with COVID, I just wanted to ask, how does it affect, research, and how do you deal with that on a day-to-day basis?
Well, right now, because my office is in the Seismic Network, I'm working from home as much as physically possible, because we want to make sure our analysts can maintain and stay on duty and stay healthy. So we're doing very strict quarantine within the network. So I am a bit restricted in, like, I'm not in my office. It makes it much more difficult to talk to your students. And so we've been doing online meetings. So that does have an impact. And field work is restricted. So that's a major impact. So right now it's just wait and see on field work, unfortunately.
Thank you.
Let's see. We have a interesting, it's a technical question from Eric Fielding. The seismicity rates, it's about one of your figures, the seismicity rate comparison between Puerto Rico and California seems to show a different B value. Is that likely a network effect?
We haven't looked that far. Like I said, I made this slide to scare the public a little bit, because I needed people to take this earthquake seriously. I think there might be a B value difference in the networks, but that's part of the reason why I kind of try to normalize it by saying 2.5 or 3.5, because I know we have completeness at those levels at both networks. So yeah, it's lies and statistics.
We've got a question from Davin Wallace, and actually, Davin, I just realized I can actually allow the attendees to talk, so I just unmuted you. You want to just ask a question? Hey, Davin.
Yeah. Yeah, can you hear me?
We can hear you.
Great. Hi, Elizabeth. It's been a while. Nice talk.
Yeah.
I
thanks.
enjoyed it very much. Nice seeing everyone as well. I just had a quick question. So, what's the magnitude of coseismic uplift or subsidence in Puerto Rico that might be associated with some of these earthquakes that you talked about?
Oh, yeah, that's all I can tell you from the 6.4. We have a GSA talk next week on that. And it was something like, and I'm saying the number, and Eric's in the chat, so he can probably put the number in there. It's roughly about 0.4 meters from the 6.4.
Okay.
So we actually have land that's been completely inundated. That is no longer usable land, and people homes are in that land. So.
Wow. Okay. And then another quick follow-up question, somewhat unrelated. When you talked about some of the amplification effects, sedimentary, sediments versus rocks, most of the population in Puerto Rico, do they live on sediment or rock, like the big population centers?
Most of it's along the coast, so I wouldn't put my money on it, but I would say primarily there's a lot of people on sediment. And even if you're in the hills, if you're in the hills, you get amplification impact just from topography. So it's a complicated problem. You can see, like, we're going to have a paper out soon on that, but you can also see there's work in Haiti where they've seen very similar impacts, where it's sediment, not only sediment, it's also topography that plays a role.
Great, thank you.
We got a question from Wenrong from the University of Nevada, Reno. Wenrong, I clicked you can talk if you want. Or you want me to ask the question? He's muted here. Okay, so let me ask his question. Yes, what does a tsunami exercise look like? Any life-saving tips? I'm sure many of us want to.
Yeah, well, the first thing, if you're in some place that is prone to earthquakes and tsunamis, know that before you go. So anywhere island in the Caribbean, most of them, like in Puerto Rico, the entire island is what we call tsunami ready. So this is run by the National Tsunami Hazard Mitigation Program. So every municipality or county has a map which shows the tsunami evacuation zone. What we teach in Puerto Rico is if you feel an earthquake that's long or strong, get gone. So if you feel it's longer than about 30 seconds or you feel shaking that you can't move safely, then you leave and you self-evacuate. And that actually happened during the 6.4, is most of the population self-evacuated because they felt the earthquake long and strong. So that was actually a good thing. It shows that the tsunami training works. So when you're talking tsunami exercise, you can go from just the most important, which is the calm. So how does the Tsunami Warning Center, which is based in Hawaii for us, are there all the comms working to us, Puerto Rico Emergency Management, National Weather Service in San Juan, and across the entire Caribbean? And that's what we test every March. And then beyond that, some people will do tsunami walks. Some schools will say, okay, we're in a tsunami zone, so we're going to have our students do the earthquake drill and then walk out and walk to where they would need to walk if it was a real tsunami. Guadalupe usually does full evacuation. And usually in Puerto Rico, we have a few towns that will do their own tsunami walk. So it's up to each member state to plan what they're going to do. I'm wearing my task team leader head for that because that's on the international level for me.
Let's see, any other questions?
I've got one about your path that you've taken. So you said you've been to Leeds, Australia, Puerto Rico. How did that transpire?
Well, I guess one, I've never had the two-body problem. So that's just the way I am. And I kind of never limited myself to saying, I only want to live in one area. And since I was younger at the time, I was like, okay, I'm just going to go to these different places. And now I moved to Puerto Rico, which is U.S. kind of sort of in between status. I moved, sorry, I took the job. It did bring me back closer home, put me in the same time zone as my family. So that was part of the reason I wanted to take the job in Puerto Rico. So when I was younger, I said, okay, I'm going to take the time. Now's the time. Go across to the other side of the world. Go to Europe. Go and live life. And I would say, do it. If you have the opportunity, just go. It's worth it.
So I have a tougher follow-up question to that. So you've experienced the world, and now you're stuck on an island.
There's nothing wrong with the island.
No, I'm just saying from the perspective of, is there something different to appreciate, basically being in essentially what is considered a small town?
It is like, well, Mayaguez itself is a bit of a small town. It's on the West Coast. So we're a bit quiet. It's not San Juan. San Juan's 3 hours away. So it's a bit quieter, which is, I like it. And one thing I do appreciate is like, I have in my backyard, I have avocado trees, banana trees, plantains. So I have essentially a functioning production garden. The downside is, because I'm in the hills, internet and power is sometimes less reliable. It's just a different way of life. And
Give you the slides.
but really, Puerto Rico is very much like the U.S. at this point culturally, as well as there's definitely a local culture as well, which is you have to appreciate. I picked up a very bad Spanglish habit.
In what little time we have left, I thought maybe you want to, I did ask you about your role in the Seismic Network. I don't think I asked, do you want to say anything about University of Puerto Rico? And it's an opportunity to say a few things.
Yeah. Well, I guess like one thing to know is that we have the only geology department in the University of Puerto Rico system in the University of Puerto Rico Mayagüez. We do offer masters and I do work with civil engineer as well because we are multidisciplinary. So there are opportunities. We have myself in earthquakes. We have people who are working on tsunamis, landslides, geochemistry, paleontology. So we have volcanology. So there are opportunities here. And so if you're looking for a challenge, things that different, and yes, you might have to learn a bit of Spanish, but I think it's a great place to come and think about if you want to go somewhere different for a graduate school.
Lots of good geology there for sure.
Oh yes.
Okay, well, yeah, anything else you want to say before we sign off?
Well, nice to see people even virtually that I haven't seen in a while. I guess the big thing I want, like any of the students watching this, is for them to remember is don't get caught on what you think is your path. And sometimes taking a left turn is a good thing. So going off the straight path and going and meandering off. Like I said, I never thought I'd be doing hazard, and here I am working in hazard. And I wouldn't trade it for anything as well.
Well, thank you. That's a perfect way to end all this. Really wise words, Liz. So once again, we all really appreciate you taking the time to meet with us, and congratulations on so much of what you've done so far, and really neat stuff. So we'll be in touch. Okay, so all the rest of you around the world, see you all later. Until next time. So I'll stop recording now. Here. Let's see how to